Hello. So some students had some trouble with the questions that we had in Purification Techniques quiz. So I'm going to go over these questions and try to solve them for you and hopefully clarify any problems that we have. All right. So starting off, the first question is basically about you have this setup where you are burning this thing. And say the diagram shows copper 2 oxide being reduced. So obviously, this is something that is usually taught in redox reactions, that copper, because it's less reactive than hydrogen, hydrogen can go over it and reduce it, which means that copper ions will convert to copper atoms. So that's something that hydrogen can do with copper 2. All right, so what's happening here? We have dry hydrogen coming in, and copper 2 oxide is being heated. You know, it's a black solid. That's a color you need to remember. So when hydrogen comes over here, it passes over this thing, reacts with it. Obviously, it's going to form H2O, and copper is going to be left over as pink solid. Again, that's a color you need to remember. Any extra hydrogen is going to be burnt off, and you know, hydrogen is flammable. In fact, it's explosive. That's why it gives us the pop test when we do it. So why is the hydrogen allowed to flow through the tube during cooling? Okay, so it says to allow the tube to cool slowly. How does that help? Doesn't really help us. To lessen the risk of explosion in the hot tube. Okay, to prevent the copper from reacting with the air. So again, what we are doing over here is that we are passing hydrogen over here, and hydrogen is going to go over copper, and if there's oxygen here, then copper that is already reduced might react with it again. So making sure that hydrogen keeps on going over it ensures that any copper that is already reduced does not oxidize again. So that's why I think this is the answer that we should have C. To remove any traces of water left in the tube, not really, because water is just going to form and steam is going to move around. Which of the following is the best method for obtaining pure water from ink? Okay, this is basically, you know, that ink is a soluble thing, and we want to get pure water from here. So how do you separate a pure liquid from a soluble solid? You distillate it. All right, so it's going to be distillation. And yeah, if you wanted to figure out what different colors make that ink, you could have used chromatography, or if ink particles were insoluble for some reason, then you could have used filtration. But in this case, distillation is the answer because it is soluble. All right, moving on, question number 3. A test tube containing a liquid X is placed in a beaker of boiling water. So you have a liquid X that was obviously at room temperature, and then you suddenly placed it in boiling water. So boiling water, we assume obviously it's going to be at least at 100 degrees Celsius. So what's happening here is that you have a liquid, which was liquid at room temperature again, and you just place it in boiling water. The liquid starts to boil immediately. What does that mean? That means, first of all, the liquid did not boil at room temperature before it was pushed into the boiling water. So while it was at room temperature, it did not boil. So its boiling point is above room temperature. But it started to boil immediately at 100. It had enough energy to suddenly break all the bonds, all the forces that it had, and evaporate, which shows that its boiling point is somewhere between the room temperature and the boiling point of water, which is why it's going to be D. Okay, moving on. Question number 4. Oxygen was prepared from hydrogen peroxide and collected as shown in the diagram. Okay, so we have manganese 4 oxide acting as a catalyst, producing oxygen that is collected over water. This method is called collection over water, and when we use this method, what this is useful for is that you can collect any gas that is not soluble in water, sparingly soluble in water, using this method. Of course, if you start it when this test tube in which you're collecting, if it is empty before you start collecting the gas, it is possible that whatever air was inside would contaminate whatever gas you collect. So for example, if this started off when water was not completely filling the test tube, then any oxygen that's coming in might also be mixed with nitrogen from the air or other gases that you have. All right, so let's look at the question. The first few tubes were rejected because the gas was contaminated. All right, so we just talked about it. The answer should be nitrogen, because before the oxygen comes in, it is possible for nitrogen from the air to also come in and collect over water here. So that's why our answer is going to be nitrogen. All right. The oxidation of ethanol to ethanoic acid is often carried out in the apparatus shown. This setup where you use condenser to make sure that any vapor that's coming out cools down and goes back. Now this is called a reflux setup. It's a condenser setup like this. It's a reflux condenser. And what's happening basically is that, let's suppose you want to heat a volatile thing. Now you can't close it off, because if you were to close this boiling flask, then it is possible that there might be an explosion. So we can't really close it off, but we do want to heat a volatile liquid and don't want it to escape. So what we do is we attach a condenser like this. Now when the vapors will go up, they will be cooled and they'll be sent back by the condenser. This reduces the risk of explosion while ensuring that liquid keeps on heating. For example, if there's a volatile liquid that you want to react, so you could use this setup and it will continue to react instead of going up. Alright, what is the purpose of the condenser? We just talked about it, I explained it. The purpose is to make sure that any ethanol, for example, over here we have ethanol reacting with an oxidizing agent. People who have studied organic chemistry would know that that produces ethanoic acid eventually. So that is why if we don't want ethanol to go away, evaporate without reacting, we might want to use a reflux condenser. So ethanol will continue to react and and if it is evaporated before it reacts, it comes back. So prevent ethanol from escaping. That's my answer. All right, moving on. Copper 2 sulfate crystals, you know the color is blue. That is a color you are supposed to know for your IGCSE or O levels. In fact, copper 2 sulfate anhydrous is used to test for water, because if water is present, it will convert from white to blue. Alright, so copper 2 sulfate crystals are separated from sand, sand being insoluble, copper 2 sulfate being soluble, using the 4 processes listed below. In which order? So this is again sand and salt, right? One is a soluble thing, one is an insoluble thing. Both are solids. So first thing, we should dissolve them. Then we should obviously filter them so the sand comes out as a residue. And after that, I will evaporate the extra water that I have and then we'll crystallize it. So in that order, my answer is going to be D. Alright, which reagent could be used to distinguish between dilute nitric acid and dilute HCl? Again, this is not really a question of purification techniques, it's more like a question of identifying different ions. So while this is not relevant, I'll still tell you the answer. If you have a halogen ion, then you can easily test it using a silver ion. So silver is going to be my answer, silver nitrate, because silver nitrate will not react with nitric acid because both of them have nitrates in it, but it will react with silver with hydrochloric acid, producing silver chloride, which is insoluble. Again, people who are in grade 9, 10, or people who have not studied identification of salts, they don't need to worry about this question. All right, this question is, I think, repeating, so I'll just skip this one. Which equation describes the most suitable reaction for making lead sulfate? Again, this is a question of preparation of salts, not really purification techniques. So I'm just going to skip this for now. A chemist wishes to separate and identify a mixture of substances using paper chromatography. You can clearly see that they run the chromatography and you have an impure solid because there's so many different spots. The solvent front is allowed to reach the top of the paper before the chemist. Oh, that is a mistake you should avoid, because now we have no idea where the solvent front is, because if the length of the paper is too small, or if water is allowed to reach the top, then it becomes really, really difficult to figure out the RF value. We do not know where the solvent front is. So yeah, this makes it pretty much impossible to use RF value. So what problem does this cause? This makes it impossible to calculate RF value. Yeah, that's option B. So I'm going to go with that. Question number 11, pretty simple question. I've seen this before. The fractional distillation apparatus shown is being used to separate a mixture of two liquids. A thermometer is missing from the apparatus. Okay. Where should the bulb of the thermometer be placed? Wherever we want the liquid to go out. Now there are two things in this setup that you need to remember. Wherever you want the vapor to go out as liquid, wherever you want the liquid to go out, that is where cold water should come in. So because I want the liquid to come out over here, cold water is coming in from here. In a reflux condenser, for example, it was over here. Because I want the vapors to come back as liquid here, water is going in from here. So that's something you need to remember. Secondly, the thermometer should always be placed in a way that it can tell you exactly where the vapors are going out from there. So the thermometer should be placed with the bulb being here. So the vapors, when they're going out, you can clearly see what the temperature of those vapors is. Okay, so it is B. All right. Which process is suitable for obtaining water? So you need a liquid from an aqueous solution of sugar. So you need a liquid from a soluble substance. Again, we have done this. In fact, this is a question similar to the previous one. So this is distillation. I feel like they're both from the same variant. Might be. All right. This is again pretty simple. I'm going to skip this one. We have done it just now. The diagram shows a chromatogram of several inks. Okay. What statement is correct? Now here's the thing. In MCQs, you might not want to calculate RF value. One, because these diagrams are usually not to scale, and second, because it takes a long time. So what you can do is what I call horizontal line test. It's not really a thing, like it's not given in your book, but it works. So if you study from me, you know I have these shortcuts and gimmicks that I just make up, and they work all the time. So for example, in this case, I want to know what ingredients are common between black and green ink. So all I need to do is draw a horizontal line test. Horizontal line, whichever drops it passes through, that implies that they're the same thing. Okay, so for example, these two, because they're on the same level, this horizontal line implies that blue and brown both have a thing in common. It does not mean that blue is present in brown or brown is present in blue. It just says that they have a thing in common. If everything that blue has is in common with brown, then blue is definitely present in brown, which is the case here. But let's look at the statements. Black ink can be made by mixing green, red, and yellow. Okay, let's see. What this means is that black can be made if all the drops of green, red, and yellow are present in black. Let's see. Red does not have a spot here. So red has this spot, this one, that is not present in black. So that's wrong. Brown ink can be made by mixing blue and red. Okay, let's see. So brown must have every drop that is in blue or red. And that's not the case because red has this spot which is not present in brown. Yellow ink can be used to make brown ink. So yellow must be present in brown. So let me draw. Yellow just has one spot. It's a pure substance. That's what it implies. It's not passing over any drop on brown. So this is wrong. Yellow ink may be present in green. Let's see. Yeah, green has a spot that is matching with yellow, and yellow only has one spot. So this is going to be my answer. Okay, good. Last question. Which process involves boiling a liquid and condensing the vapor? So you're boiling a liquid, condensing the vapor. That is distillation again. So there you go. So those were the answers to the quiz that we did in class. I would suggest that you watch Purification Techniques and Experimental Techniques video again if you're still having trouble with it. And if you have any questions, feel free to send those to me. All right, I'll see you in the next class. Take care. Bye-bye.